This lesson is on derivatives of inverse trigonometric functions. As a recall, we know that if y equals to sine inverse of x, it means that x equals sine of y. So if we want to take the derivative of y, we can use x equals sine of y and use implicit differentiation to take the derivative, and then we will need to use some trig identities to derive the formula for y prime. And if we do that, we will have the following theorem, which is for derivatives of inverse trig functions. So the first formula we have is derivative of sine inverse of x equals to 1 over square root of 1 minus x squared. Well, normally the range for, the domain for x is between negative 1 and 1, but because for the derivative formula we have square root of 1 minus x squared in the bottom, so we cannot take the value negative 1 and 1. Therefore, x can only take value between negative 1 and 1, but not including negative 1 and 1. Similarly, derivative of cosine inverse is negative 1 over square root of 1 minus x squared. Again, x cannot take the values of negative 1 and 1 because we have 1 minus x squared in the denominator of the derivative formula. Then we have derivative of tangent inverse equals to 1 over 1 plus x squared, and because 1 over 1 plus x squared defines everywhere, we don't need any restriction on x. Cotangent inverse, derivative of that equals to negative 1 over 1 plus x squared, and similarly, similar to tangent inverse, we don't need any restriction on x. The fifth formula is derivative of secant inverse, and this looks a little bit complicated. It is 1 over absolute value of x multiplied with square root of x squared minus 1, and the restriction on x is that the absolute value of x must be greater than 1, and that is to make sure that the square root is defined and then the denominator is not 0. And then the last formula is cosecant inverse derivative equals to negative 1 over absolute value of x times square root of x squared minus 1. As you can see, derivative of cosine inverse is almost the same as sine inverse, except that it has a negative sign. Similar for cotangent inverse with tangent inverse, almost similar with the negative for cotangent, and same thing for cosecant and secant. As you can see, the negative sign goes together with the co-function. So cosine will have a negative, cotangent will have a negative, and cosecant will have a negative. Well, these are the formulas. So if you remember the formula, you should be able to find the derivative, right? The trouble may come when we have to combine these formulas with chain rule. For example, we have f of x equals cosine inverse of 3x squared. As you can see, it is a composition of two functions with the inside function to be 3x squared. So we're going to have to use chain rule here. And if we let u be the inside function, which is 3x squared, then the derivative of our function becomes the derivative of cosine inverse of u. Then if you use the formula for cosine inverse, you'll be able to get negative 1 over square root of 1 minus u squared, which is exactly the derivative of cosine inverse, as you can see on the left hand side. But because u is a function of x, chain rule says that we have to multiply with u prime at the end. There you go. Now all you need to do is to substitute u, which is 3x squared, back into the derivative. And therefore we have that multiplied with 3x squared prime. And if we compute everything out, we get negative 1 divided by square root of 1 minus 9x to the 4th multiplied with 6x. Next example. G of x equals secant inverse squared. So again, we have a composition of two functions here with the inner function, the inside function, to be secant inverse of x. So then the derivative of g becomes derivative of u squared, which equals to 2u, but chain rule says that you need to multiply u prime at the end because u is a function of x. Then again, all you need to do is to substitute u, which is secant inverse of x, back into the derivative. So you get 2 times secant inverse, because secant inverse is u, and then derivative of secant inverse, which you can see on the left hand side, should be 1 over absolute value of x square root of x squared minus 1. And that's the lesson.